ईयर स्टूडेंट्स, अगर आप इन वीडियो लेक्चर्स का मैक्सिमम यूटिलाइजेशन करना चाहते हो तो आई थिंक आपको ये इंप्रूव सेशन डेफिनेटली फॉलो करना चाहिए और रिलीजियसली फॉलो करना चाहिए। इंप्रूव सेशन क्या है, इसका लिंक डिस्क्रिप्शन बॉक्स में है, तो जाओ उसको चेक करो। इसके अलावा अगर आप व्हाट्सएप ग्रुप ज्वाइन करना चाहते हो, और मुझे लगता है आपको करना भी चाहिए, तो आप क्या करो, हमारे वेबसाइट पे जाकर के अपने कॉन्टैक्ट डिटेल्स दे दो या फिर इस व्हाट्सएप नंबर पे जाकर के अपने कॉन्टैक्ट डिटेल्स दे दो, सो दैट हम आपको उसमें ऐड कर सके। चलो अब पढ़ना शुरू करते हैं।
Hi, welcome back. This is the second video in the kinematic series, and in this video we'll be learning about motion under gravity, and that is going to fall under two cases. One is going to be the 1D motion, and that is basically vertical free fall, and the second one is 2D motion or the projectile motion. Okay, so we'll start with a few derivation in the 1D free fall motion, and then we'll move on to basic projectile motion. Okay, and I do have a separate video about the meeting of two different projectiles, and that I'm going to cover in the next video. Okay, so let's do very basic derivations regarding the 1D motion. Suppose I have a particle that is starting from this point, and this point is on the ground, and starting with initial velocity u. It's thrown with initial velocity u. So if you think about the trajectory of the particle, it's going to go up, then it's going to stop, and then it's going to come back. Okay, so let me give you a statement here. Suppose this starting point is O, and again the maximum point is A. So time of ascent is basically the time it takes to go from O to A is same as the time of descent, and that is basically the time it takes to go from point A to point O. Okay, time of ascent is time of descent. Again, this is one statement. I'm going to prove it in a while, and I'm assuming there is no air drag, so this whole motion is happening in absence of any kind of dissipative forces or air drag. And one more thing, the velocity with which it's thrown, or the speed with which it's going to be thrown at t is equal to 0 is going to be the same speed with which it's going to land back on the ground. So let's say the incoming velocity or the speed is v, so this v is going to be equal to u, or if I'm going to write in modulus form, so this v modulus is going to be u modulus. Is basically saying the speeds are going to be same. So if you're having that knowledge about the conservation of energy in absence of the drag force, you should be able to see that at the same point your change in gravitational potential energy is 0, so your kinetic energy has to be same. So that's why the speeds have to be same. Okay, so let's derive this first thing. Time of ascent is equal to time of descent. So if starting from u and goes to final velocity 0, so we can use v is equal to u plus at, and if the final velocity is 0, this is going to be 0, and u I'm taking upward positive and downward negative, so it's going to be u minus g into t. So t is going to be u by g. This is your time of ascent. Okay, now if I'm taking the motion from, now this was the motion from O to A. Now let's talk about the motion from A to O. So at A my u is 0, and the body is going to go down, and we are concerned about finding the time of descent. So while this body was going up from O to A, the corresponding distance traveled, or let's say the h, that can be calculated using v square is equal to u square plus 2as. So final velocity is 0, u square is going to give you u square, and this is going to be negative sign, minus 2 into g into s. So s is going to be u square by 2g. So this will be the height it's going to take, or also the maximum height, u square by 2g. And so if I'm going to use this equation, while it's coming back it's going to travel the same distance, so u is equal to 0, s that has to be traveled is from A to O is u square by 2g. So I can use this equation, v square is equal to u square plus 2s, but wait, I have to calculate time, so s is equal to ut plus half at square. So this s is equal to ut, initially was 0, ut plus half into downward. Now for AO motion I'm taking downward positive, I can change that anytime. So for AO path I'm taking downward positive and upward negative, so it's not going to change anything. So this u square by 2g is also positive because I'm taking from A to half A, instead of A I'm going to write g, half g t square. Okay, So this thing half gets cancelled out. This t square is u square by g square, or t is u by g. This is the same time of ascent. This was also u by g, and this time of descent is also u by g. So time of ascent is time is equal to descent. And if I'm talking about the total time is going to take, the total time, this is time of ascent plus time of descent, that is going to be 2u by g. Keep in mind, this total time is the time it takes to go from point O and then come back at the same height. So suppose if I am having this scenario when the particle is thrown from this height and it goes up and then it comes to ground. Okay, so in that case I cannot use this 2u by g. If the particle is thrown with a speed u, this 2u by g is going to be used for this path. Okay, this path, just going from this point O to A and then coming back to O. This whole path is not going to be 2u by g, just this upward part, because it's coming at the same point. Okay, now the next thing I'm going to prove, that if the body is coming back at the same height, the speed of the body is going to be same. So if suppose if I'm going to throw it with a speed of 10 meter per second, it's going to go to some maximum height A and then it's going to come back at the same level, the speed of the body is going to be same as 10 meter per second. So let's prove that. Now assume the body is thrown from this point O and initial velocity is u is equal to u, okay, or v is equal to u. It goes to a point A, and at this point the velocity is going to be 0. Okay, and I know from the previous derivation that this time going from time O to A is u by g, and also the time is going to take to come back, okay, from this point, this time A to O is also u by g. Okay, so now think about it, how you can use this information to find the velocity of the body at this point. So now think about it, if I'm going to release if the body is going to come from A to O, for that path A to O the initial velocity is 0. So if I'm going to use v is equal to u plus at, in this case final velocity when it reaches point O and the initial velocity is at A, so this is suppose v, that we have to calculate. U is 0 because at maximum height it's going to be at rest. This is 0 plus A, instead of A I'm going to write g, and this t is nothing but u by g. So this is going to give you v is equal to u. So we have proven that the speed of the body when it's going to come at the same height is going to be same as the initial thrown speed. Okay, so here is a sample problem for one-dimensional free fall. We have two particles. One is at a height 40 from the ground and it is being thrown with a speed of 10 meter per second, and so assume this is a tower of height 40 meter, and the second particle is being thrown at a speed of 30 meter per second from ground. Okay, and they have asked time of flights for both particles, that means how much time this particle and this particle like they are going to spend in air, and the second is position of particle 2 when particle 1 is at maximum height. So when this guy reaches its maximum height, and so it's going to stop at the maximum height, and at that instant I have to figure out the position of this particle 2. And the third one is a little bit tricky and you have to be really careful regarding this calculation. Will they meet? If yes, find the time and the corresponding height from the ground. Okay, so if they are going to meet, the height of both particles from the ground is going to be same. So either you can calculate the height of this particle or this particle. If they are going to meet, it's going to be same. So we'll have to do a little bit of analysis if there is a possibility for these guys to meet or not. So let's proceed. First of all, I'm going to find the time of flight for this particle, because this is going to come to ground and we already have a formula for that. When one particle goes up and comes back at the same level, I have a formula for that, that is 2u by g, right? So that time is basically 2u by g, u by g going up plus u by g coming down. So for particle 2, time of flight for particle 2 is basically 2u by g, and that is 2 into 30, and I'm taking g is equal to 10, and this is 2 into 3, 6 seconds. So this has to be 3 going up and 3 coming down. Now think about the calculation of time of flight for particle 1. Now particle 1, this particle 2 went something like this and then came back to this. I'm not sure whether this is going to cross this 40-meter barrier or not, so we'll have to see for that, but this will be the general path of the particle 2. Okay, but for the particle 1, it's going to go up and then it's going to come down. Okay, so remember, we cannot use this formula 2u by g for particle 1 because the particle 1 is not ending its motion at the same level, right? So it's starting at here and it's going to fall somewhere here, so we cannot use this formula for particle 1. Although what we can do, we can think about the motion of the particle 1 in two different scenarios. Okay, so particle 1 is going to go here at point A, it comes back at the same level, call it this point A dash, and then it's going to come back. So let's see the motion for particle 1. It's going to go and then it's going to come back. This is at the same level at which it was thrown, and then it's going to come to ground. Now we can use this formula 2u by g just for this O A O interval. Now let's suppose the ground point is B, so total time is T O B, and that is basically T O A O plus T O B. Now we can use the formula 2u by g for this calculation, and this has to be calculated separately. Okay, so T O A O is again 2u by g, and for particle 2u is 10, so this value is going to give me 2 into 10 divided by 10. This is nothing but 2 seconds. Okay, so this value is going to be 2 seconds. Now think about how we can calculate TOB. Now this TOB at point O, the particle has a downward speed is still 10 meter per second, that we have proved, okay, in like the in the start of the video. So this is going to be the up was 10, so again the down speed is going to be 10 meter per second. And now think about, we have to travel a distance of 40, so for this motion I'm going to take downward positive, so the distance to be traveled is 40. I'm going to use s is equal to ut plus half at square, so this 40 u is 10 t, s is equal to ut plus half into a into t square, so this is 5. So 5t square plus 10t is equal to 40 is nothing but t square plus 2t minus 8 is equal to 0. Okay, I'm just dividing everything by 5. Okay, so this t square plus 2t minus 8 is equal to 0, and the roots of this equation, I'm going to ignore the negative t, so this t is minus 2 plus root over b square minus 4ac divided by 2a, 4 plus 32 divided by 2, and this will be minus 2 plus root over 36 is 6. 6 minus 2 is 4. 4 divided by 2 is 2 seconds. Okay, so this value is 2 seconds, and we already had this value 2 seconds, so this 2 plus 2, it becomes the total time, it becomes 4 seconds. Okay, so time of flight for particle 2 is particle 1 is 4 seconds, and for particle 2 it was already 6 seconds. Now there is one more important thing that I need to mention. Okay, so what let me first erase this thing. Okay, so now when I calculated the time for particle 1, I did a scalar calculation. What I did, I calculated the time for this part, and then I separately calculated the time for this part, and I got 4 seconds. Okay, and for particle 2 I got 6 seconds. Now I could have gotten this t1, the total time of flight for particle 1, in just one single equation using the vector formulation. So if you have seen the first video, we have this vector formulation, s is equal to ut plus half a t square, or s is nothing but the displacement. So in that case you might notice that this is basically rf minus Ri is equal to ut plus half a t square. Now in this case that r stands for the vertical position. Okay, so now first I'll choose a coordinate. So for this motion I'm going to choose coordinate at this point only, and this will be my origin. I'll take upward negative and I'll take downward positive. Okay, so Ri in this becomes 0, downward is positive, so Rf is 40. So the equation is going to look like 40 minus 0 is equal to ut. U will be negative, as per the convention use negative, so this will be minus 10t, and plus again downward is positive, so acceleration is going to be positive, plus, and I'm taking a is equal to 10, so half a is going to be 5t square. So notice these are the end values. So this is the final position, this is the initial position, and these are the basic parameters u and a. So whatever time I'm going to get will be corresponding to the end position. End is 40, initial is 0. So the displacement of the body is going to be downward 40 in time t, and that basically is my time of flight. So I should be getting the same answer 4 seconds by solving this simple equation. Let's see if we are getting the same thing or not. So if I'm going to divide the whole thing by 5, I'll again get t square minus 2t and minus 8 is equal to 0, and the solution is going to be t is equal to 2 plus 4 plus 32 divided by 2, and this is 32 plus 4 36, 6 plus 2 4, 6 plus 2 8, 8 divided by 2 is 4. So indeed I'm getting the same answer as the previous one. Okay, so we are done with the first part. Let's talk about the second one. Second one says position of particle 2 when particle 1 is at maximum height. Okay, so 1 is going to be maximum at maximum height a, and the time it's going to take is u by g, is basically the time of ascent. Okay, so for particle 1 to reach the maximum height, the time is going to be u by g, and this u by g translates to 10 by 10 is equal to 1 second. Okay, so it's going to take a time of 1 second to go from point A to point O to point A. So this is 1 second, and so what is the position of particle 2 in 1 second? I can just use s is equal to ut plus half at square equation. S is equal to ut plus half at square, and this u is 30. So I'm taking upward positive and downward negative, so 30 into 1 minus 5 into 1. Okay, 1 square, so 30 minus 5 is going to be 25 meters. So the particle 2 will be at a height of 25 meter from the ground when particle 1 is at the maximum height. Okay, now comes the third part. It's the most important part. Okay, so listen carefully. Okay, so for this solution, before we start writing some equation and then start solving for t, let's just think about it, whether there is a possibility of meeting or not, without doing any calculation or calculation for the meeting part, just with some normal results. Okay, so this particle 1 is going to take 1 second to go up and then 1 second to come down. So it's think about coming back at the same height. The time period is going to be 2 seconds. Okay, now think about the time period for this second guy that we already calculated, that is 6 seconds for the total time, and it's going to take 3 seconds just to go up to its maximum height. And this first particle is going to take 2 seconds to complete this path. Okay, so while this guy is still going up, right, the particle 1 is already it has already covered it's this loop and it's going down, so they have to meet. Okay, so if this doesn't seem very obvious to you, pause the video and try to convince yourself why this has to be the case. Okay, now we are sure of that these particles are going to meet. We can just directly solve for s1 is equal to s2, or where s is going to be the vertical position. Okay, so I'm going to fix, for this calculation I'm going to fix my origin here at the ground. Okay, and let me just get rid of this calculation. Okay, so I'll take my origin here and upward positive, and I'll take downward negative. So I'm just going to solve for particle 1 vertical position is going to be same as particle 2 vertical position, keeping this point as origin. Okay, so what is the general position of particle 1 as a function of time? It's already at initial displacement of 40. So again we know this RF is equal to Ri plus Ut plus half a t square, where Rf is the final coordinate, Ri is the initial coordinate, and these terms are self-explanatory. So for this particle 1 I'm going to write y1. Y1 will be, y1 is basically the final position of particle 1, so it's going to be 40 plus 10t minus 5t square. I'm taking g is equal to 10. Similarly for y2, since initially its Ri is 0, so it's going to be 0 plus 30t again minus 5t square, and this value has to be equal to this value. So if I want to solve for it, this and this gets cancelled out, and this 10t goes to the right, and then it becomes 20t. 20t is equal to 40, so t is equal to 2 seconds. Okay, so these guys are going to meet at t is equal to 2 seconds. Okay, and if yes, find the corresponding height from the ground. So the corresponding height from the ground is going to be basically the position of any of these particle at t is equal to 2 seconds. So if we just think about the particle 1 at t is equal to 2 seconds, is just at the same height or same level. So these guys are going to meet just at point O, or the initial position point of particle 1. So at a height of 40 meter from the ground they are going to meet. Okay, so this t of meeting is going to be 2 seconds at height of 40 meters. Okay, so this video is already getting very lengthy, so I'm going to quickly go through the 2D motion. Okay, free fall, like the basic of projectile motion, and then we'll do problem solving and the discussion of assignments and stuff in the next coming videos. Okay, so let me just clear it. Okay, so in basic projectile motion we have this simple scenario. A particle is projected from a given point O, and then it completes its motion and then again lands at point A. Okay, and this OA distance is your range R, and it attains a maximum height of h. Okay, so again these derivation for the range and height are like very dead easy, so I'm not going to derive that. I'm just going to talk about the main points that I'm going to use for the future videos. In this case, just keep in mind there is no acceleration in the x direction. The only acceleration is the vertical acceleration, that is your g. Okay, so if there is no acceleration in x direction, this initial velocity, that is u cos theta in the horizontal, and the vertical velocity is u sin theta. So this u sin theta is going to change because of this g, but this u cos theta will not change because there is no ax. So if I'm going to use v is equal to u plus at in the x direction, that becomes vx is equal to ux plus ax into t. This term goes to 0, so vx is always going to be equal to ux. So always at any given point the horizontal speed of the particle is going to be u cos theta. Okay, and again the vertical speed is, or the vertical velocity is going to change. Again I'll just give you a quick overview. This particle is coming back at the same point, so that vertical displacement is going to be 0, and using this you can calculate your time of flight, and then using that time of flight and you're going to multiply that time of flight into u cos theta, and you'll get your range. And similarly using, you can just figure it out how to calculate the maximum height. The final vertical velocity is going to be 0, and using that v square is equal to u square plus 2s in the vertical direction, you can find your h max. Okay, so this is the single most important result. You can figure it out in this case, that is horizontal speed is going to remain constant, and that is basically the speed of the particle at the maximum height, because at maximum height Vy is 0 and the only speed that I have is ux, and that is u cos theta. So at this point it's u cos theta. Okay, so in the next video I'm going to take two different particles, okay, and we'll talk about the possibility of those guys meeting in general space. Okay, see you.